Good afternoon, I am Renu Sharma, Assistant Professor EC Department. Today, we will start with the next part of this ongoing topic, that is network layer delivery, forwarding and routing protocol. So, in the previous lecture, we have discussed about unicast routing protocol, Dijkstra's algorithm, where we have to find the shortest path and we have to update the routing table every time. So, in this lecture we will going to discuss the unicast routing protocol once again, the continued version, and then we are going to discuss about the multicast routing protocol. So, in case of this multicast routing protocol, the router may forward the received packet through several of its interfaces. So, basically in case of multipath, if you are going to see, so this is the source address which is written over here, because in every packet it consists of some information that will acting as a source, that will acting as a header. In the header it consists of the source and the destination address. So, if you can see that this is the source and these are the different nodes which are connected, like this is G1, this is G1. So, all these are written over G1. So, it will going to this particular packet will going to be transferred to different intermediate nodes. These are the packets which are considered over here. So, this is G1, this is G1, these are the different intermediate nodes which are written over here. So, this is it will going to path follow to the different interfaces. Whereas, in case of this unicast routing protocol, the router forwards the received packet through only one of its interfaces. So, interfaces means it will going to follow only one path. If you are going to compare this diagram with this one, that from every node, like let us say this is router 1, this is router 2, this is router 3, this is router 4, router 5 and this is router 6. So, let us say there are 6 different routers are there. So, at every point there are 3 different paths which are connected through this router. So, if this is the incoming one, outgoing will be the three options are available. So, these are the 2 options available. In this case, these are the 3 options. So, at every router you have the choice to transmit the particular packet. In this case, here only there are 3, it is been forwarded to 3 different points. Here only it will going to forward it to 2 different points. So, this is the multicasting. The router may forward the received packet through several of its interfaces. In case of this unicast, if you are going to compare with the previous diagram, it will going to follow only single path, means it will there are also 3 different options are available at this router, but it will not going to follow to this particular line. So, it will be transferred from this point to this point, only a single path will be followed for transferring of packets. Next one is multicasting and multiple unicasting. So, what is the difference between multicasting? As you have seen that in case of multicasting, a particular packet will be received at the router. So, at the router there are 3 different paths are available. So, the packet will be transferred to any of one of the path. In case of unicasting, it will going to follow only single path between the host A to host B, that is from the source to the destination. So, this is the multicasting versus multiple unicasting. This is source A, this one, these are the different nodes which are connected over here. This is router 1, router 2, 3, 4, 5 and 6. So, these are the different routers which are connected over here, and these nodes which are followed, these are the packets it will going to follow. Like at this point there are 2 different nodes are there, at this point there are 2 different nodes are there. So, this is how the data will be transferred from this path to this path. So, this is the case for multicasting. In case of multiple unicasting, the same procedure will be followed, but you can see that multiple packets can be transferred over here. Like here the packet will transfer from here to here, the packet will be transferred from here to here. So, this is how the packets will going to follow from this path through this path. So, this is source 1, this is destination 4 which is been written over here. So, this is multiple unicasting operation. Next one is shortest path tree in unicast routing. So, in this case if you will see that what is the shortest path which is considered tree in the unicast routing is there, like this one is network second, this one is network third, this is network fourth, this one is 5, 6 and so the different 5 networks are connected in this case. This is the router 1, this is router second, this is router third and this one is router 4 which has been connected over here. So, this is the shortest path table is been there, this is the destination that is showing the next hop. Like if the packet is reached to this network 1, then the next hop will be nothing. If the packet will reach to this network N2, then the next hop will be R2 as in this one. If the packet is reached to network N3, then the packet will again it will be transferred to R2. If the packet is reached to N4, then the shortest path will be R2. So, you can see over here that it is connected to this particular hop. So, this is the shortest path tree and this is the routing table which is maintained at this point only. So, this is based on the next hop operation. So, only it is written that what will be the next hop at a particular point. Next one is source based tree approach. So, in this case source based tree approach, these are the different nodes which are connected over here. This is routing table which is maintained at router R2. This is the routing table which is maintained at router R3. This is the routing table that is denoted by R1. This is the routing table which is denoted as R4. So, these are the different routing tables. This is the shortest path tree and these are the different nodes which are written over here. This is again these are the destination and this is the next hop. Only it is written that what will be the next hop, like this is R2 R4 will be the next hop, then this is R2, this is R2, this is again R2 R4, this is again R2 R4. So, these are the next hops which are available to which the data will be transferred. These are the destinations, like G1 is the destination, G2 is the destination, G3, G4 and G5. So, these 5 are the destination points, means source we have to consider, and in this routing table it is written that if it is reached to G1, then if it is want to reach to G1, then what will be the next hop available. If it wants to reach to G2, then what will be the next options are available. So, this is been written over here. This is 5 shortest path trees are there. So, these are the shortest path which are considered. Next one is group shared tree approach. In case of this group shared tree approach, there are different groups are available, that is denoted by G1, G2, then this is denoted by G1, G2 again. So, these are the different routers which are written over here, that is denoted by R2, this is denoted by R3, this is denoted by R1, this is denoted by R4, and this is the core router which is been presented over here, and the routing table which is maintained at this core router will be denoted by here. This is having the shortest path tree, this is again having the shortest path tree. This is core router table. So, these are the destination paths which are available, like this is G1, this is G2, G3, G4, G5, and these are the different hops are available, like this is having R2, R3, R4, then R2, R3, R3, R4, R4. So, this is group shared tree approach, means a particular group will be shared in a tree formation for a particular network, and these all groups are connected to a core router which is being shown over here. Now, next one is the taxonomy of common multicast protocol. This is the taxonomy. Now, you can see over here this is multicasting protocols. This is showing the source based tree. Now, this source based tree is nothing, it is showing this MO SPF, this is showing this DV MRP, this is PIM. Now, PIM is connected to this PIM DM and PIM SM. So, these are the source based tree and this is the group shared tree which is based on this CBT. So, these are the examples of multicasting protocol. In case of multicasting protocol, at every point the packet can be transferred to different routes to which this particular router is connected. Let us say there are 3 different routes, output nodes are there to a router. So, the packet will be transferred to all the 3 nodes only. So, that is the case for multicast protocol. Examples are source based and group shared tree. Now, this is group shared tree with rendezvous router. Now, what is this one? This is the shared tree. You can see these are the members which are connected to different routers. So, these routers are forming the rendezvous router. Like you can see that this member is connected to this router, this member is connected to. So, 2 members are connected to router C, one member is connected to router E, one member is connected to router D, and no member is directly connected to this network, this router and this router. So, it is connected through different routers only. So, this is the group shared tree with this particular type of router. This will act as a rendezvous router, where it is connected to different intermediate routers only. So, that is also a kind of case which is a part of this group shared tree, and indirectly it is related to multicast protocol. Now, next one is logic tunneling. Now, what is logic tunneling? You can you have seen this diagram earlier in my lecture in ATM. In case of this asynchronous transfer mode, tunneling is used. Basically, what is tunneling? Whenever different devices are connected to a network, let us say this will act as a logic tunnel, and here there are virtual paths, that is VC, virtual channel and virtual paths are connected. So, more than one virtual channel is connected to single virtual path, and more than one virtual path will going to connect to this logical channel, or you can say that this will be the transmission path, TP, denoted by TP also. So, TP is nothing, it is a part of the physical layer that is also a part of OSI model, that is the last layer. In the physical layer, this logic tunneling is there, where the actual logic or the actual packet of information will be transferred. Like this is the logic tunneling, this is router R1, this is router R3, this is router R2, this is router R4. So, basically 4 routers are there, these are connected through different networks, and these are the intermediate routers which are presented over here. These are the different routers, this is router 1, this is router 2nd, this is router 3rd, this is router 4. So, likewise different routers are connected, and these routers are nothing, it is connected to different logic tunnels. So, this is how the network will be formed over here. Now, next one is the M-bone. M-bone is nothing, it is a kind of network which has been established. This is a network which has to be followed, like these are the different routers are there, like this is the first router, this is the second router, this is the third router, and this is the fourth router. So, these 4 routers are going to follow this kind of network is known as M-bone. In this case, if you can see that this is consisting of the multicast group address, this is consisting of the source address. So, this is the source address to which particular data has to be delivered. So, this is nothing, it is the source address. This is the multicast group address. So, this is denoted by G. This is unicast source address, where in case of unicast, whenever a particular packet will be transferred from one node to another node, then intermediate routers are considered that will acting as a unicast source, where only one particular path has to be followed. So, that is a case for unicast source address denoted by router R1. This is the unicast destination address denoted by the router R2. So, from this particular diagram, it is clear that this is the source address from which this packet has been generated, and this is the group address. This will act as a source address for router 1, this will act as a destination address for router 2. So, this path has to follow. So, the packet will be received over R2, because this will act as a destination address, then it will be transferred either to router 4, that is denoted by R4, and it will be transferred to router R3, that is denoted by 3 over here. So, this is the concept of M-bone which is been shown over here. So, this is how the packet will be generated from a particular router, it will be transferred to another router over the network. So, in this diagram if you can see the multicast protocols, there are different techniques which are used, like first one is the MOSPF. This is the technique which has used, this is the technique which has been used in this case, that is DVMRP. Then if you can see that this is common in source based tree and group based tree. So, that is also dependent on this destination M, and this is denoted by the source M. So, this is how the packets will be changed. That is a case for multicasting protocol. In this case, that is the source based tree which I have already discussed. In this case, that is the source based, it is consisting of the source information which is having this group address, that is denoted by G1, G2, and this particular table is maintained at this router 1. This is a router 1 table. If I want to deliver a packet to this G1 point, then it has to follow the path, that is R2 and R4. So, any one of the path it can follow. If the particular packet has to be delivered to G2, like from here to G2, then the packet will be, next hop will be acting as an R2. If this packet has to be delivered to this G3 from this point to G3, from this R1 to G3, then it has to follow R2 only. If packet has to deliver to G4, like from here, the path which has to be followed is R2, R4 or G4. It can follow this one, it can follow this one, because G4 is available at both the points. Now, the next one is the G5, where it has to be, if the packet has to be delivered to G5, so only one G5 is available. So, it has to again follow R2 and R4 path. So, any of the path it can follow to reach to a particular point, like it can follow this one, it can follow this one, through this point is there, through this point G5 is there. So, any of the next hop we can consider in the source based tree. In case of this group shared tree approach, a common group root is there, that will acting as a core router, and different networks are connected, like this is router R1, this is router R2, this is router R3, this is router R4, and different groups are there, like this is the destination. This routing table will be maintained at this core router. If I want to transmit the data to this G1, then it can follow to R2, it can follow R3, it can follow through R2, because G1 is present at all the 3 destination points. Now, in this case, when we are considering the G2 one, so G2 is present at all the points. So, R2 and R3 both can be considered, that from R1 it can be transferred to through R2, it can be transferred through R3 also. In case of G3, if the data has to be transferred to G3, then this particular group has to be considered, that is following this G3 case. In case of G4, it can follow the path R3, it can follow the path R4. If it is G4, then it can follow the path R4 also. So, that is the core router table which is been shown over here. So, this table, this type of table is maintained at the core router, where different routers are connected to a single core network, and this core router will act as a root of this particular network which has been followed. Now, these different groups, like which is denoted by G1, G2, G3 and G4, all different networks are connected. All these networks are basically may be connected to ARP, that is the automatic repeat request protocol. It can be connected to different routes also, like it can be connected to different networks also, it can be connected to WAN, it can be connected to ATM, it can be connected to frame relay operation also. So, these are the considerations which are being made over here in case of this group shared tree protocol. Next one, in the previous slide I have also discussed about the routing protocol, where in case of this routing protocol which will going to follow the shortest path, which is considering the shortest path algorithm. In case of Dijkstra's only, what we have seen that if I want to transfer the particular packet, let us say this is a network which is having 4 nodes. This is node 1, this is node 2, this is node 3, this is node 4, and all these networks are connected like this one. This is showing the path length, or you can say the cost of connecting this network from N1 to N2. What will be the cost? It will be 2. To connect the network from N1 to N4, what will be the cost? It will be 3. So, at every node, this is the Dijkstra's example. At every node I have to decide that which is the shortest path. Let us say if the packet is received over here, then I have to consider whether this one is shortest or this one is shortest. So, among the two cases 2 and 3, this one is the shortest case and it will going to connect the network from N1 to N2. Second case is when the packet is reached over, let us say over here, then there is no options available. So, it has to be connected to this point only, which has the path length 5. At this point the packet can be transferred to this one or this one. So, I have to take the decision, then 4 will be the shortest path length. So, this is how path will be selected and the data will be transferred from the path length, that is denoted by the cost which are mentioned over here. So, that is denoted by the path length. And also when we are transferring the data in Dijkstra's algorithm, two types of tables are considered. First one is the temporary table, second one is tentative list, and the second one is the permanent list. So, whenever I have to take the decision, I have to enter the particular entry in the tentative list. When that particular path is fixed, then it has to be entered in the permanent list. So, this is how the Dijkstra's routing algorithm will be decided. So, this is the this slide is showing the multicasting versus the multiple unicasting, where it has shown the difference between if the unicasting is done multiple times, then you can see that multiple packets will be transferred from this source to these different destinations. So, this is the multiple unicasting. In case of multi unicasting, you can see that every packet will be transferred to the every node which has been connected over here. Now, you can see that single packet will be transferred to this point and this point. Now, this packet is received over here, this will again going to be transferred to this point and this point. So, 3 different outputs are there of this particular router. Then this packet will be received, it will be transferred to this G1 point only. This packet will be transferred to this one and this one. So, this is the case for multicasting. Multicasting means at every point I have to decide that which particular path has to follow, it will be delivered to every other different point. So, that is the case for multicasting. In case of multiple unicasting, the unicasting is done at every point, it will be done once, but the number of packets which will be transferred, it will be more than one, but it will going to follow the common path. Like you can see that this packet will going to follow this path, then at every router you can transfer the different packets. Like you can see 2 packets will be transferred to this router and 1 packet will be transferred to this router, and the remaining one will be transferred or forwarded to the next router. In the same case, 2 packets are there, it will be going to followed, and at the reaching destination, this is the last router is there which is connected over here. This is the destination router, you can say. Then 2 packets are incoming to this router and it will be delivered, 1 packet is delivered to D4, 1 packet is delivered to D5. So, this is the case for multiple unicasting, where only single path will be followed and you have to transfer the packets in a bulk, and at every point you have to transfer the packet at this point, this point, this point, and the remaining computers or nodes which are connecting to this network. So far we have discussed about unicasting protocol, then multiple unicasting protocol, multicasting. So, all three things are different, how the routing tables are maintained, how this source based tree approach is there. Then there we have discussed about group shared tree approach, where a core router is there, where different groups are connected. These groups, as I have mentioned, that these groups are nothing, these are the connecting groups which are connected to different networks. These are extended to different internet, also it is extended to ARP, that is nothing, it is the automatic repeat request protocol, where if a particular packet is not received at the destination, then a request has been sent after a automatic time that that particular packet can be received further, can be transmitted again. So, that is a case for automatic repeat request protocol. In that there is a timer which has been set at the source side, whenever we are going to transfer any packet to the destination, then that timer will start. Then after, before ending of the timer, if that particular acknowledgement is not received, then at the end of that timer, that packet will be transferred again from transmitter to receiver, because there will be two conditions are there, whether it is affected with noise or whether it has followed another path. So, it has not received to that particular destination. So, we have discussed about this group shared tree approach. Then we have discussed about multicasting protocols, group shared tree, then tunneling, which is associated with ATM only. Then this was the last topic, that was MBONE, where the source address, multicast group address and unicast source address are mentioned in this packet which has been formed, which is consisting in the header part of this particular frame. So, these are the references that that you can go through for this particular topic, that is unicasting and multicasting protocol. Thank you.